Hello everyone, welcome back to my channel. Today let's go over a medium level question that I just resolved on my own after over a year, so I'm super happy about this and I'm very glad that I was able to come up with my own solution to this question without any help after over a year. So as you can see, apparently I tried it a bunch of times last month, but first did it August of 25th, 2024, and I came back to it and I was just able to do it completely on my own. So yep, let me show you how I did it. 1358, basically, you want to return the number of substrings that contain A, B, and C, right? So let's come up with a brute force approach. So first, this is going to be n squared, right? Just check every substring. So if there's at least one character, we're going to add it to the hash map, right? So if C has A, and C has B, and C has C, then we're just going to increment it by 1, right? Just we want to count the number of substrings that are valid. So this is fine, but it's n squared, and this is going to time out. So if we see an A, then we're going to add this to the hash map. If we see a B, we're going to add this to the hash map. And then if we see an A again, it's going to be like this. So this is obviously a problem, but what we can do is, if you notice, so let's say a substring is A, and then AB, and then A, B, and C. So we're finally valid. We have a valid substring at this point. So if we know this is valid, there's at least one, then we know the rest of the substrings are also valid. So we can just add the length of S minus the most recent valid point with the right pointer, right? And then break it. So that makes it much faster because we don't have to check all the other substrings, but this is still n squared in the worst case. So let's see if we can make it even faster. So this is the first optimization I tried. So 53 out of 54, very close, but the way to do it and the way I came up with is to use a sliding window approach, right? So we're just going to keep adding. So as long as the window is satisfying, so AB, ABC, so as long as the window is satisfying, then we're going to count we're going to count all the substrings to the right. So length of S minus this pointer, because that's how many substrings are satisfying, and then we're going to shrink the window until we're not satisfying anymore. So this is not satisfying, so then we can break the loop and we can go on and B, C, and then A. So right, so we're going to do this, we're going to shrink the window, and it's not satisfying, so then we can keep going on, and we're just going to keep shrinking as long as it's satisfying, and then counting the number of substrings that encompass this, at least validate the criteria, right? So while C of A and C of B and C of C and left is less than or equal to right, because we can't keep shrinking if there's nothing there, then we can say answer plus equals to length of S minus right, right? Because if this is valid, then everything, all these substrings are also valid, because we're at least satisfying. We can only add, right? We can't subtract. So in that case, we would just shrink the window. So if C of S of left is equal to 0, then delete C of S of left, and then increment the left pointer, right? So this is much better because now the time complexity is O of n instead of n squared. We're not recomputing the substrings, right? So let's run this. Okay, so C is counter. Let's run this, submit it, and there you go. Passes all test cases. So again, I'm super happy that I was able to come up with my own solution to this question without any help after over a year. So that's it for this video, and thank you for watching.